Hello everybody, that's our first tutorial into Stiff3D, our little educational software for linear elastic analysis and form finding with the force density method. We assume that you have installed Excel on your desktop, the desktop version of Excel, and you have downloaded what I have sent you or what you have downloaded from the cloud, the Stiff executional Excel projects, Stiff3D, and eventually some input files and this extra folder here with additional bitmaps and things like that which are necessary to run Stiff. Okay, to run Stiff, we just give a double click to Stiff3D. Excel will be just starting, and what is opening is here the first table, the preprocessor table, with some further buttons here just to import input files, to export projects into other to new input files, or you're able just to switch into languages, Deutsch, German or English. To run Excel, the best is you just click into this little figure here. Then we get to the message table where the latest extra information is just given about news in Excel and in Stiff. You may read them here. There's just some additional information here. So, and to finally starting Stiff is just pressing here this button, continue with Stiff. What opens is that window which is split into these 4 views. Top left you see the XY projection of our object. Left bottom you see the XZ projection, bottom right the YZ projection, and top right you see the perspective view with a complete central projection, which we can just rotate by pressing the left button of your mouse, keeping pressed and moving the cursor around to modify the view. So the basic idea of Stiff is just having these available views, which we may maximize or minimize eventually, just pointing into the off of one of these views, right mouse button of your mouse, the right button of your mouse, going down to maximize, and you may maximize a respective view. The other way around, pointing to the off, pressing the right button, and we go back to minimize. You see already the basic idea of Stiff, that every of the items what you see are context sensitive. That means if you just go with the cursor, with the mouse to any of the items, for instance here this node, pressing the left, in this case we can select it or deselect it, or the element, we're just pointing in it, pressing selection, deselecting it. Or if you just push the right button, you receive just this related context menu here for the node with many other additional information with respect to the coordinates, the degrees of freedom, the kind of load what you apply, and all these others, or here the displacement values after some analysis. So that's to say it's true for any of these objects. If you just go to the element, press the right button, we just receive here the respective element context menu for, in this case, element number 8. So we can also come to this context menus by double click to the node. Here we are at the node. Double click to the element. You can do it in any of the views here, in this case here, or even also here in the perspective view. Double click at these elements or items, objects, you just receive the respective context menus. And to deactivate, again pressing, just pointing at this element and selecting them. We can also make use of the rubber band to activate elements, or deactivating. Here with all these within the rubber band we can deactivate, or deactivate all of them, just selecting nothing within your rubber band, and there we are. The other basic element of Stiff is this vertical menu bar on the right hand side with few of buttons, where we can just take a look at further options regarding the grid, the node, and so on and so forth, or the graphical user interface. Then here calibrating means that we are calibrating the mouse eventually. Once in a while it might be necessary. Then here grid, switching on, switching off the grid. If you look carefully, you see these little points here, or here the grid in the 3D view. If we activate it or deactivate it, it's visible or not. Here we can activate or make visible the undeformed original grid, original object here, undeformed. So it's not visible, now it's visible. Or here the deflected here, D for deflected, or we can make visible both of them, the undeflected, original, or the deflected one. We can make visible the supports. They are switched off now, and we can switch them on. And if we switch them on, we can also select here a mask, which of the bounding conditions should be visible or not. We can switch on the load or switch off the load, self-explaining. Refreshing means draw again the graph if it's necessary. And here the four most important buttons, the select mode, curation mode, analyze mode, or the animation mode, which simply mean that in the select mode, which is now activated, we can select and deselect elements, but it's not possible to create something, or more important even to delete something. So the safeguard mode. So, and the curation mode, I think that's self-explaining. That is what you have to switch on just to be able to create items. So to be more specific, without further selecting what you would like to select to create node or elements, you have to activate these guys also. Here you see activating node. And if I just go here with my cursor into one of these views and press the button, you see what I did. I created a node. If we try it a second time, you see I'm not successful, simply because you see this button has been deactivating in the moment when I just have created a node. Just observe this button node to the right. I do it again. So just observe it. I go to here. That's easy to observe what happens. If I create a node, this is deactivated in the same moment. The idea is just again to be on the safe side, not to create more nodes as necessary. However, of course, it's quite often the case that you would like to create many nodes at once, and then you have to activate this button by a double click. I put a double click on node here, and now you see we are ready just to create as many nodes as we would like to do. Okay. Element, I think it's self-explaining. If we push element, we can create a straightforward directly element with two nodes at the beginning or the end, or we can just take an existing node and just connect it with another existing node, just to create an element. Okay, then you see here the support conditions signed, and they are understood relatively to the view. So that is the vertical and the horizontal support condition, and that one in the third direction for the respective view. If we just start here for the YZ view, and I just select this node, then we have a vertical boundary condition, support conditions, as you see, a horizontal one, which in this view is that one in the Y direction. You see it also here indicated in that view, for instance, the Y direction is that one, which is normal to that view. So if we just put it off, here you see it. Here we have this vertical one. So if you would be here in this view and you would take off the Y support, in that case that is this simple. That is the respective Y support in that view. And then we have also the possibilities to switch on support conditions for the rotations, rotation around the Y-axis in this case, rotation around the Z-axis in this case, or if you switch into here, the rotation around the X-axis, which again is this indicator here, which in this view will be this bullet, this filled, this little square here. Which means rotation around the third axis, which in this view is the X-axis, equivalent to this direction or that direction, for the respective views. Then we can take away all the support conditions for the selected nodes with the minus sign, or we can put on the complete set of boundary conditions with this little button here for all the selected nodes. Now I have put away all these nodes which I just have created additionally, just to be able to show you what are the next steps. So then the next would be, after creating the input and operating on that, do the analysis, pushing analysis, and you see we directly hop into the animation of our results. You see it here by automatically this button be activated. Animation is understood like that. If I just again go into one of these views, press the left button of the mouse and push it up or down, and by that we are just simulating some animation of the deformation. What is done is that we are operating on the scaling factor. Just go to the bottom right here, the scaling factor. So if I push the left mouse button and move the bottom, you see we are just increasing or decreasing the scaling factor. It might even be negative. That means just the direction of the load is inverted by that. So we're getting back to positive scaling factors, and by that you see we can just play around and just do some animation of our deflection. Then we have these 6 buttons here. For the stress results like normal force, torsional moment, and the 2 bending moments My and Mz, and also the shear forces for distribution. And if you would like to know specific values of one or the other element, you simply activate this element and you see, or perhaps just take another one here, this one here, you see we just receive the respective detailed information of this element with respect to the local orientation of its coordinate system. Again, we switch off all this detailed information and may finish our analysis simply by pressing here at the bottom right, save and quit. We save everything and we quit Stiff, and we come back to our tables in our EXA project. Here we are at the table preprocessor, and if you go through all the other tables, you may now find all the data which we have created or operated through our interactive application of Stiff, all the nodal information, the system information, with the topology, the cross-section material properties, and so on and so forth, cases, the stiffness matrix, or you see here the tables for the normal forces distribution of all the elements, the shear forces, the 2 with respect to the local coordinates y and z, mx, that's the torsional moment for every of these elements, my and mz, the bending moment with respect to the local coordinate systems. One of the most important other table is that one. It's called setup, and here you see all the project parameters which have been created automatically or have been triggered by you. Important is that one here, this cell B1, the top here, the second column. If you just here write in force density or standard or all, you may just affect the layout of the interactive view of your GUI. I will show you that eventually when we come to the point about how to specify Stiff for using for the force density method for form finding. Okay, going back to the leading table, and that was the first introduction into the principal layout of Stiff. Thank you.